2.5 Zeros of polynomial functions. All right, we kind of set the groundwork with our division the other day on finding zeros of polynomial functions. So we're going to work on it now. So a couple things that we want to talk about here is what are possibilities when we have a long polynomial, and this can be a polynomial of any degree from the first to 25 or whatever. There are a limit to what could be a possible rational zero. Okay, and this is, and again, this is coming if they have integer coefficients, which I'm going to be honest, I don't see a lot of those without integer coefficients. But we're going to find our possibilities by putting P over Q. Okay, now, right now you're saying, well, what's P and what's Q? The P's are all the factors of our constant term. Okay, so our constant term is the last term at the end of a polynomial. We're going to look for all of its factors, and then we're going to place those over every combination of the Q, which is the factor of the leading coefficient, so whatever is in front of our highest power. And this gives us the possibilities for our rational zeros. Okay, so quick reminders, rational zeros, those are whole numbers, those are integers, those are anything that can be written as a fraction, right? Those are the zeros we're looking for. Don't forget, there's always imaginary zeros or complex ones that are also possible, but that's not what we're looking for right now. We're looking for possibilities of our rational zeros, okay? So let's look at the first one. All I'm doing right now, when it says the rational zero theorem, that's putting our P's over our Q's to figure out what are my possible zeros of this function. So for P, these are all the factors I can think of my constant. I prefer to put them in numerical order from like lowest to highest. So 1 could definitely go in there, and that goes in 15 times. I kind of make my list front and back because then I catch both of them. 3 goes in 5 times, and to be honest, that's all of them. So I'm just going to leave it 1, 3, 5, 15, okay? For Q, those are any factors of my coefficient. My coefficient is 2, so I have 1 and 2. Okay, and sometimes we're like, do we need to list the 1? Definitely. For what our job is, we want to. Okay, so there's my P and my Q. To find my possible zeros, I want every factor of my constant term over every factor of my my coefficient, my leading coefficient. Okay, so I'm going to start off with my 1 over my 1. That's just 1. 3 over 1 is 3. 5 over 1 is 5. 15 over 1 is 15. All right, now I'm going to put everything over the second one, the 2. So 1 over 2 is 1/2. 3 over 2 is 3/2. 5 over 2 is 5/2. And 15 over 2 is 15/2. None of those are the same, so those are all distinct. And to be honest, I've listed half of them right now. Okay, and this is the reason. Every time we have a factor, we have to think of, well, what if it was positive or what if it was negative? So that means that I could have a plus or minus 1, a plus or minus 3, a plus or minus 5, and somebody reading this is never going to see those minuses, a plus or minus 15, plus or minus 1/2, plus or minus 3/2, plus or minus 5/2, or a plus or minus 15/2. Now, it seems like a lot when you think about it. 1, 2, 3, 4, 5, 6, 7, 8 times 2 is 16. That means there's 16 possible zeros. It is a lot, but I'm going to be honest. There are 4 roots, so there's a chance 4 of those could be answers, right? So that's, we're up to 16 of them, but there's also so many other numbers out there, especially when you start thinking you can use fractions, that at least we narrowed it down to the 16 it could be, okay? So that's what we have to think of. And as we go through these, we're going to do more than just list them, okay? All right, for number 2, it is in descending order. Always check, because you would hate to grab the wrong P and Q off of there. So P right now is -3, or just 3. Factors are 1 and 3. Q is 4 here, so I have 1, 2, and 4, okay, for my factors of that. Okay, I need every combination that these can make, okay, P over Q. So I'm going to do 1 over 1, that's 1. 3 over 1 is 3. I'm going to do 1 over 2, that's 1/2. 3 over 2, that's 3/2. Now I'm going to do 1 over 4, that's 1/4. And 3 over 4 is 3/4. Okay? So there's all my list. I used every combination I can. None of them are the same, so I'll leave them all. And of course, I get the plus minus on each of those. So this one has a combination or a possibility of 12 different real possible rational zeros, okay? So that's how we make our list. And as we go through here, now we're going to use this to keep guiding us through so we can actually find those zeros. All right. So what we're doing here this time is we're going to list all the possible rational zeros. Then we're going to use synthetic division to test to see which one actually works, and use the quotient from part B to find the remaining zeros. Okay, so some key ideas I want to go over before we do this. I have 2x cubed. That means possibility here of 3 zeros, okay? So I have a possibility of 3 zeros. In fact, I should have 3 zeros. Now, we need to consider, though, they could be complex, which means they're not going to solve out properly here. They could be 3 of the same. Don't forget that sometimes you have a multiplicity in there, so they could repeat. But we should be able to get some type of zero. Because it is a cubed and it's odd, we know it has to cross the x-axis somewhere, so we should be able to get at least one, and from there, we can go through and find the other ones, okay? All right, first things first, we need to find the possible rational zeros by listing our p over q's. So my p here, I have 6, factors are 1, 2, 3, and 6. And my q has factors, that's my 2 of 1 and 2. Okay, so p over q, I have a possibility of 1 over 1, which is 1, 2 over 1, which is 2, 3 over 1, which is 3, 6 over 1, which is 6. Then I put the 2, so 1 over 2 is 1/2. 2 over 2 is 1. I already have it on my list. I don't have to repeat it. 3 over 2 I don't have. 6 over 2 is 3. It's already on my list. I don't need to repeat it. All right, there's my list, okay? So if you happen to repeat them, it's not like it's a big deal. It's just make sure you don't double do the work later. Okay, and don't forget, everything is plus or minus. All right, so once again, we have 12 options here. Okay, now, I'm going to be honest, this is kind of the dreaded step, because here's the deal. We have 12 possibilities. It says use synthetic division to test the possible rational zeros and find an actual zero. We're guessing and checking, and we have 12 things to guess and check until we find something. So hopefully it doesn't take you all 12, but you just start and you say, well, which one might work, okay? Now, how do I know if one of these works? Well, if I use synthetic division, I am looking for a remainder of 0, right? Well, that didn't help me out at all when I try to write with a highlighter. All right, so don't forget, to test the possibles, we're looking for 0 remainder, okay? If you find 0 remainder, then you know you have a 0, possible root, okay? All right, so let's just start. Let's put 1 in there. So we put 1 in the corner. Everything's in descending order, x cubed, x squared, x, and then a constant, so we're good there. So 2, -3, -11, and 6. Bring down the 2. 1 times 2 is 2. Add them together, I get -1. 1 times -1 is -1. -11 and -1 makes -12. 1 times -12 is -12, plus 6 makes -6, okay? Because I get a remainder, this one is not going to work, okay? Let's try -1, right? It's right there. It's easy to multiply. Bring down a 2. 2 times -1 is -2. I get -5. -5 times -1 is 5. I bring down a -6. -1 times -6 is +6, which gives me a 12. Once again, it didn't work, okay? Let's try another one. Did anyone else get one and they know? Something suggests we're going to do here? You want to try 2? It's next one in line. And, of course, we like whole numbers, right? 2, -3, -11, 6. All right, I bring down, I get a 2. 2 times 2 is 4. Bring down a 1. 1 times 2 is 2. Subtract, I get -9 times 2 is -18. Get -12. Another no. Let's try -2. So -2, 2, -3, -11, 6. Bring down a 2. Times -2 is -4. That gives me -7 times -2 is 14. with a negative 11 makes 3 times negative 2 is negative 6. Ding, 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 we found one. All right, because I get 0 here, that's what I was looking for, I have found a root. So negative 2 is one of my roots. It's one of my zeros, okay? So once you find one, we now have made the problem easier, okay? Because this is 1, there's 2 left. That means if I take this line right here from when I found one, that's my remaining factor. So to be honest, what we have right now is an x plus 2 factor, because that's what that leads to. And then we have 2x squared, because it goes down 1 power, minus 7x plus 3, okay? So that leads me into what we can do. This, right now, is a quadratic. I can graph it to see where it crosses the x-axis. I can take the square root. I can complete the square. I can factor it, or I can do the quadratic formula to solve it. So I've now brought it down to a problem that I have a method of solving, okay? I don't have good methods of solving x cubes, I'm going to be honest. So by finding one factor and pulling it out, and then leaving what was left, we can continue to factor it. All right. Oh, this is one of my 2 times 3. 2 times 3 is 6. Factors of 6 are 1 and 6 and 2 and 3. Which pair of those add to make 7? 6 and 1, right? Okay, so I'm going to leave my x plus 2. Okay, 2x squared and 3. If you remember, I take this 7 and I split it into my 1x and my 7x, okay? What signs do I need? I'm sorry, not 1, not 7. My bad. Okay. How about 1x and 6x? There we go. This one already had a plus. What signs go on 1 and 6 so they'll make negative 7 in the middle? They both get a negative. All right. That means the first 2 can factor. The only thing I can pull out is an x, and I'm left with 2x minus 1. On the back side, the last 2, I could factor out a 3. I'm going to actually factor out a negative 3, and that will leave me with positive 2x minus 1. All right. Do I have any more room on my paper here? I do. All right. So that gives me the factor of 2x minus 1 with the factor of x minus 3. And don't forget, I already had this x plus 2 that I brought from earlier. All right, I have fully factored that big trinomial that wasn't a trinomial, I'm sorry. The polynomial with a power of 3, I have 3 factors. So it must cross at negative 2, it must cross at positive 1/2, and it must cross at 3. Those are my 3 solutions, my 3 y-intercepts, my 3 zeros, the 3 roots, however you want to call those, okay? So we use synthetic division to test the possible rational zeros and find an actual 0. Then we use that quotient from part B, that was this the trinomial there, to find the remaining zeros. So we solved it doing that, okay? So if I put these in, if I put these in my set notation, I have negative 2, 1/2, and 3, okay? Is it an easy and fast process? No, but it's doable, okay? So we list the possibles, use synthetic division to test them, and then take our remaining one and go from there. The key is once you find one, work to make your equation smaller, because the smaller you can make it, the more it is able to be solved, okay? To be honest, we could have used this, let me change colors here so you kind of know where I'm talking about here. We could have used this right here, and we could have done more synthetic division with that. And we could have done more guessing and checking. Because if you notice, 3, well, that was one of my choices up here. 1/2, that was one of my choices up here. We could have continued to guess and check all the way through all 12 of those until we found the 3 that worked. But to be honest, usually we're looking to shortcut us, and once we get it down to a process where we can do it in a different way, we like to go back to our old ways, which we know are kind of foolproof if we do our math correctly, okay? All right, page 2. Let's try one more of these, and key on this one, how many possible answers could we have? Yeah, we could have 4, right? We could have 4. We know there should be 4 zeros. We don't know how many of them are rational, how many of them are complex, how many of them repeat, but there should be 4. Now, just giving us this idea, anytime we have even powers, there is the slight chance that there are no rationals. If everything on that graph happens above or below the x-axis, it might not cross. So keep it in the back of your mind. We're going to hope that's not true. Okay, is my polynomial in highest or lowest degree? Yes. All right, my p's are my all factors of my constant at the end. So 4 has factors of 1, 2, and 4. For my q, any coefficients of my leading coefficient. It's 1, which makes it super nice. It's just 1. Okay, so my p over q's, I can either have plus or minus 1, plus or minus 2, and plus or minus 4. Okay, that's not bad. Only 6 to choose from, and there's a possibility of 4. All right, what do you want to start with? You want to start with, I don't know, 2? Let's start with 2. Okay. First, -2, -5, 8, and 4. That's the 4th power, 3rd power, 2nd power, 1 power, no power, right? Go down. 1 times 2 is 2. I get a 0. 0 times 2 is 0. I bring down -5 times 2 is -10. I get -2. -2 times 2 is -4. Hallelujah, we found one right away. Okay. Possibly I knew that, but anyways, put it out there. Okay. So right away, I know that 2 works, okay? Now, I'm going to take what I have here, and rewrite a new polynomial, okay? So think about this. This is now x to the 3rd. There is no x cubed, but you know what? I'm going to write this because it's going to help me. I'm sorry, x squared minus 5x minus 2, okay? That's my new one. Well, it's still a cubed. I don't have a good method to solve a cube, so I'm going to just go right back into synthetic division, okay? I'm going to have to make a guess, but I'm going to have 1, 0, -5, and -2. I'm going to go off of what I got from the earlier one and keep rolling. All right, do we have a good guess? I'm going to try -2. Okay, -2. Bring down my 1. -2 times 1 is -2 plus 0 is -2 times -2 is +4. Subtract again, or add. I really add, but because one's negative and positive, I get -1. -2 times -1 is +2, and I got another one. Yay! All right. So once again, I found a second root. So I know 2 and -2 work. Just key things here. It's not always true that if the positive works, the negative works on a rational number. Okay? I'm going to throw that out there because you're going to see something different come up when we start doing some with the complex. Okay? All right, we found 2 of our answers. There's a possibility of 2 more. We have to see if they are or if they aren't. Okay, so I get this equation because I used to be x cubed, now I'm x squared. 1x squared minus 2x minus 1. Okay, I'm going to come over here. X squared minus 2x minus 1. Are there factors of 1 that subtract to make 2? No. So factoring's out of the possibilities. Let's do quadratic, right? My a is 1. My b is -2, my c is -1. Okay, opposite my b, so 2 plus or minus the square root of -2 squared, that's my b squared, minus 4 times my a of 1 times my c of -1, all over 2 times my a of 1. Okay, so that gives me 2 plus or minus. 2 squared is 4. I always keep my minus. 4 times 1 times -1 is -4. All over 2. That gives me 2 plus or minus the square root of 8 all over 2, which is 2 plus or minus 2 square root of 2 over 2. All of these outside 2's can reduce, and I get 1 plus or minus the square root of 2. Okay? Obviously, that is not on my list of rational zeros because a square root is not rational, but because I got it down to a quadratic, I had another method of solving so I could find these 2. Okay, so if I list my zeros here, I have -2, 2, 1 plus the square root of 2, and 1 minus the square root of 2. Okay, there are my 4 zeros for those. Now remember, 1 plus the square root of 2 and 1 minus the square root of 2, those are decimals. Okay, they're not pretty by any means, but it means that that graph is crossing the x-axis 4 times. That's why I got 4 solutions there. Okay? And by the way, if you want to write these as just 1 plus or minus the square root of 2, I'm fine, as long as we recognize those are 2 separate roots, because they'll give you different decimals. All right. Properties of roots of polynomial equations. So if a polynomial equation is of degree n, then counting multiple roots, you get n solutions, okay? We've already been going over that. We've been saying that since we started the first problem we were finding the answers at. Whatever the degree is, that's how many answers you should get. And we keep in mind, they could be rational, they could be complex, they could be irrational with radicals, okay? So different ones, they could repeat, so you could get the same thing. One of the key ideas when we go into complex roots, okay, is that a plus bi, if this is a complex, it has the imaginary number, if a plus bi is a root, then a minus bi will also be a root, okay? And remember, just on the problem above, I said just because 2 is a root doesn't mean negative 2 works, but in that case it did. So on real numbers or rational numbers, it's not always true that 1 and then the opposite is its answer. But on polynomial with complex roots, you do get that the conjugate is also a root, okay? So imaginary roots, if they exist, occur in conjugate pairs. So if 1 is the root, the opposite is also the root, okay, the conjugate. I shouldn't say the opposite because the a doesn't change signs, just the bi. Okay, so we're going to write and find the polynomial that has these answers. So first things first, my degree is 3. So that means when I get, and I'm working on this, that I should eventually get an x cubed as my highest degree because there's 3 roots is what it's telling me. Okay, 4 is one of the roots and 2i is a root. So it gives me 2 of them, okay? So if 2i is a root, negative 2i also has to be a root. Anytime you have something complex, its conjugate is also a root. So I actually know my 3 roots, 4, 2i, and negative 2i. That means I have enough to start my function. Okay, so I'm going to say, we need to step back and say, what does it mean to be a root? Well, that means if I factored, I got the factors of x minus 4, x plus 2i, and x minus 2i. Okay, that's really where this is coming from. Now, our job is to multiply them out, okay? And don't worry, I didn't forget about this. We just don't need it quite yet. Okay, I'm going to be honest, these two multiplied out together first is probably the best bet, and you'll see why when we simplify it. So let's FOIL those two out. We're going to ignore the x minus 4 for a slight time. FOIL. I'm going to get x squared for my first two. Outsides, I get negative 2xi. Insides, I get positive 2xi. And last two, I get negative 4i squared. Don't forget to square that. That's important. What's beautiful here is my middle two terms cancel, and I'm left with x squared minus 4i squared. Don't forget I squared is negative 1. So if I take negative 4 times negative 1, I get positive 4. Okay, so all of that multiplied out to x squared and plus 4. And then don't forget I still have this x minus 4. So now I'm going to FOIL again because I still just have two polynomials here. Okay, so I'm going to take these and I'm going to FOIL these again. All right, so first times first gives me x cubed. Outsides, x times 4 is 4x. Insides is negative 4x squared. And last two with negative 4 times 4 is negative 16. Okay? So right now, I have this function. And in order, I'm going to write x cubed minus 4x squared plus 4x minus 16. Okay. No, I'm not done because that's the most basic form. But what if we had a GCF that actually divided out already? Okay, we don't have that right now. And that's where this function value comes in at, okay? So what happened is maybe, and I say maybe because not always, there was a GCF we factored off, okay? I'm going to call it A. I need to see if there was an A, and I'm going to plug it. I'm going to find that A. Okay, so what we do is we're going to plug in for f of x, and for every x, from this value I got right here of f of negative 1 equals negative 50. Okay, so I'm going to use that to see if that A has a value. Okay, so my f of x, or my y value, is the negative 50. I put that in over here. I'm trying to solve for A, so that's still my variable, and I'm going to plug in this negative 1 everywhere I see an x. So I get negative 1 cubed minus 4 times negative 1 squared plus 4 times negative 1 minus 16. Okay? So time to do some math here. Negative 1 cubed is 1. Negative 1 squared, I'm sorry, it's negative 1. Negative 1 squared is positive 1 times negative 4 is still negative 4. 4 times negative 1 is negative 4. Negative 16 is negative 16, obviously, or minus 16. So when I do the math there, negative 1 minus 4 is negative 5, minus 4 is negative 9, minus 16 is negative 25. So I get an A times negative 25 equals negative 50. Well, to solve for A, I'm going to divide, obviously, by negative 25. Okay. If I tell you that I'm not a huge fan of technology, but hey, it's helping us do some of this, right? Okay. Of course, no, I was already at the end of my paper. Okay. I divide here, and A equals 2, right? If I divide by negative 25. Okay, this is important. I almost had my equation right here, but I had to check if the A was something. I did find a different A. So now my job is to multiply everything in there by the A. All right, I'm trying to find a spot where I can find my, you know, I'm going to just change colors so it's a little more obvious. Okay, so now I'm going to take my f of x, and I'm going to multiply by that 2 that I just found for A times everything. Okay, so my final equation for this function that has zeros of 4 and negative and 2i and negative 2i, because we know that, is going to be 2x cubed minus 8x squared plus 8x minus 32. Okay, so you're going to use your roots to multiply out and find your base of your polynomial. Solve to see if you have an A, and then if you do, take it and put it onto that function, okay? All right. You're saying maybe we should do one more of these? Maybe we should, just for more practice, right? Okay. So as we look at number 6 here, the key thing to remember is, what should my final equation have? I see n equals 4. That means I should have a final equation of x to the 4th, okay? Obviously with some other things. I have a root of negative 4, 1/3, and 2 plus 3i. If I have 2 plus 3i, I also have 2 minus 3i, okay? So remember, anything in the complex also has its conjugate, okay? Not its opposite, but its conjugate. There's a slight difference, and I know I wasn't saying it correctly earlier. Okay, so let's write these as roots or factors, okay? So x minus 4 would come from x plus 4. 1/3 would come from x minus 1/3. And I'm going to do a quick note for you there. X minus 1/3. If I don't like the fraction, I can multiply by 3, and I can get 3x minus 1 equals 0. So if you want to change this to 3x minus 1, that's fine, because that's really where that came from if you think of the factors, okay? Then I have, now be careful here, x minus 2 plus 3i, because we always subtract the roots, and x minus 2 minus 3i, okay? So over here, because of this minus going through, I get x minus 2 minus 3i. And then this one is x minus 2, as this distributes through, plus 3i, okay? All right, and of course we have these two over here. Okay, so what I'm going to do, because I have 4 of them, this isn't going to be pretty in any way, shape, or form. I'm going to FOIL my first two. So I get x squared minus x on the outside plus 12x on the inside minus 4. And that goes to x squared plus 11x minus 4. Okay, so that's my first two. I'm going to FOIL the last two. You always want to combine your complex ones together, because it usually should take out those i's and they'll disappear. Okay, so I can't really FOIL this, okay? I'm going to take x times everything over here. So I get x squared minus 2x plus 3xi. Inside, or I should say the middle term, I'm going to get negative 2x plus 4 minus 6i. All right, the last term, negative 3i with everything. Negative 3xi. If you write ix, it's fine. They flip-flop. It doesn't really matter. Positive 6i and negative 3i squared. Okay, what's a chance somebody's going to be able to read that? Okay, so this simplifies to x squared. It's the only one I have. I have a negative 2x and a positive 2x that cancel. I have a positive 3xi and a negative 3xi that cancel. I have a negative 6i and a positive 6i that cancel. Okay, so I have this, no, you're right, I made a mistake. Okay, never mind, here. I need to fix this. I had a negative 2x from the first one, and then on the second one I had another negative 2x. I thought I had a positive 2x, so that actually makes negative 4x, right? Okay, so those two are still here, negative 4x. Okay, then I have my plus 4 here, and I have a minus 3i squared. Well, remember, I squared is negative 1 times that negative 3 makes that a positive 3. So my 4 plus 3 I'm so confused right now. How about, okay, once again, never trust the teacher. Have I told you that before? Don't trust me. Okay. This was a positive 6i. Negative 3i times 3i here at the end should be negative 9i squared. Do you sit there waiting to see how long it takes me to find my mistake? Because you're like telling me, but I obviously can't hear you from your house. So here I sit making multiple mistakes. All right. How about negative 9i squared? I squared is negative 1, right? And negative 1 times negative 9 makes that positive 9. There we go. 9 plus 14 makes this 13. Okay. I think I'm not okay. X and 3x. How about 3x squared? Okay. It's a good thing I have a piece of paper sitting here that has my old work on it so I can catch myself on all these mistakes since you're not here. Okay. I think we're okay now. So the first two foiled out to 3x squared plus 11x minus 4. The second two we couldn't really foil because of the 3 terms and 3 terms, but I think it's simplified down to x squared minus 4x plus 13. All right, now the last task of multiplying these two together. Okay, so 3x squared times x squared. I think I can get this right this time. 3x to the 4th. Next two terms, 3x squared times 4x is going to be negative 12x to the 3rd. And then 3x squared times 13, which should make 39x squared. Okay. Next two. 11x and x squared is 11x cubed. I'm going to put it right underneath the other one I already have for like terms. 11x times negative 4x is negative 44x squared. Again, I'm going to put it underneath there. And then 11x times 13 is going to make a positive 143x, and there's no x right now, so that one's going to hang out. Okay, last one. Negative 4 times x squared is negative 4x squared. Again, I'm going to line it up with the other x squareds. Negative 4 times negative 4x is going to be positive 16x, and negative 4 times 13 is a negative 52. Okay, what's the chance you can trust me on this multiplication? I'm double checking with my old work here. I think I have all the signs right and stuff. Okay, so what does that come out to when I join my like terms? So f of x right now, and remember I'm going to leave this a because I'm not sure. So far I have a 3x to the 4th, a negative, right? Negative 12 plus 11 makes negative x squared, or x cubed, I'm sorry. My x squareds, I have 39 minus 44 is negative 5, minus 4 is negative 9x squared. 143x and 16 makes 159x. Minus 52. Nothing goes with that one. Okay, so I think I have that. Now I'm going to need to check to see if I have an A. Okay. So let me change colors here, and maybe this will keep people straight. Okay, so I'm using this right here to check for my A. So I'm replacing this with 100. I'm trying to plug here. If you're okay with this, I'm going to try to do as much math. Because x is 1, there's not a whole lot here. So 1 to the 4th is 1 times 3 is 3. 1 cubed is 1, so I get minus 1. 1 squared is 1 times 9 is minus 9. 159 times 1 is going to be 159. And then I still have this minus 52. Okay, so that gives me 100 equals A. I'm doing all this math here. And I'm just going to grab a calculator, so hopefully I don't make more mistakes. 3 minus 1 minus 9 plus 159 minus 52 equals 100. which is beautiful because that means a equals 1, which means my final equation will just be f of x equals, and it's what I started with here, right? Let me give myself a little more room since I've already proven I can't write it in that space. F of x equals 3x to the 4th minus x cubed minus 9x squared plus 159x minus 52. Okay, so turn all your zeros into factors, multiply those factors out, watching your algebra, don't trust your teacher, and then always double check with the point given to you if there is an a that needs to be multiplied a factor times all of your other terms, okay? All right, let's move on to Descartes' Rule of Signs, okay? And I'm going to tell you I'm not exactly a great French speaker. I think that is one name I actually say correctly, okay? I think, but I'm not positive. Okay, I call it Descartes' Rule of Sign. And Descartes' Rule of Sign basically found that there's a pattern to what happens when you have sign changes in your polynomial as to what kind of roots or zeros you might have, okay? So I'm just going to kind of read through these. And again, this is something that I'll put here on the video, I'll put the examples, and there's a chance you might watch it a couple times, just this little section to say, okay, is this sinking in yet? Okay, we're going to take a function, and we're going to count the number of sign changes on the function. Okay, that's what we're counting is the number. So just the function as it is, we'll count its number of sign changes, okay? So the number of sign changes it has is the possible chances of how many positive roots we might have, okay? Now, it's that number plus or any less than a number of sign changes by a positive even integer. I know that doesn't make sense right now, but go with me right here. And we keep going down until we get to 0, okay? And then to find out there's a chance of negative real zeros, we do f of negative x, kind of like when we check for the even or odd. And then we count the number of sign changes again, and that helps us with the with the negative possible roots, okay? And then from there, we can determine if there's complex or not, okay? Or what the possible combinations are, okay? I want to stress this right now. It doesn't really solve anything. It gives us a possibility. So maybe if we know we can't guess more than 2 positives, once we get our 2 positives, we stop because we know there can't be more, okay? So it kind of narrows down how our guesses might happen. All right, so let's check this one right now. So we're going to start, okay, and I'm going to tell you right now. So I'm looking for positive roots or positive chances, okay? Negatives. And the other option, if we have them, are imaginary. Okay, I'm just going to put an I there for imaginary. Okay, so the first thing we want to do is take our function and count how many sign changes. Well, this is currently positive. This one's obviously negative. This one's positive. This one's negative, and this is negative. So I changed once here. I changed a second time. I changed a third time, but since I stayed negative, that's all. I have 3, okay? 3 sign changes, which means I have a possibility of 3 positive roots. Or I subtract an even integer. So to be honest, just subtract 2, okay? Let's just say subtract 2. Okay, subtract 2 until you get to either 0 or -1. You can't have -1. So 3 minus 2 is 1. Obviously, 1 minus 2 gives me to -1, and I don't want that one. So I'm just going to say 3 or 1, okay? Now, I'm going to try for my negatives. Okay, so for my negatives, I want to find f of negative x, which means I'm going to plug in negative x into the 4th. I'm going to plug in negative x into the 3rd. I'm going to plug in negative x into the squared. Plug in negative x into my first power minus 6. Okay. Negative x to the 4th is not going to change signs. It's going to cancel out, and I'm just going to be left with 4x to the 4th, and that's positive. Negative x to the cubed will be negative times that negative will make it positive x cubed, so now I have another positive. Negative x squared is not going to change a sign. I'm just going to leave it 5x squared, so that's also positive. Negative 2 times negative x will change to positive 2x, which will stay positive, and then I have this minus 6 at the end, which is negative. Okay. So as I go through and I plugged in the negatives, and I check the new sign changes to see what happens, right? And again, this is something that the more you work with it, the more you might be able to just look and know, and maybe you don't write out the work. But don't be afraid to write out the work to test this. Okay, so once again, I'm seeing, okay, so I start out positive, 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 positive. Here is my first and only sign change, okay? That means I only have one chance of a negative, okay? Possibly of one negative. Actually, I need to say that. There is one negative, okay? It's not just a possibility. There has to be one, because if I do -2, I'm down to -1. I can't do that, so there has to be one negative. Okay, so here's my choices. Okay, this is the basic, okay, this is like my rule up here, and then I can go from here. Okay, if I have 3 positives and 1 negative, that would be 4 roots. I wouldn't have any imaginary, okay? Or if I had 1 positive and 1 negative, that would give me 2 roots. I need 4 answers, which would mean I'd have to have 2 imaginary, okay? So to be honest, these are my choices right here of the roots for this equation, for this polynomial. I either have 3 positives with 1 negative, or I have 1 positive and 1 negative, and I never have, and then I have 2 imaginaries as well, okay? Either combination will get me my 4 answers. Those are my choices. So when it's time to list your P's over Q's and say which one of these should I start guessing, I'm going to tell you right now, you want to guess at least 1 negative, because you know you have to. Now, you also could have 3 positives you could guess, or 1 positive. So again, it tells me that in my list, I better get some answer, because I should have at least 1 positive and 1 negative, or I can have 3 positive and 1 negative. So Descartes' rule of sign basically tells us and narrows us down. You could guess. These are the guesses you could get, okay? All right, last one, and we're going to practice this. Practice kind of everything we know to see if we can narrow down what we should get, okay? So first things first, I have my polynomial. Order is descending. I have all that I need to know. I should, when I get done here, find 4 answers, okay? We're going to try to do everything I can to get my zeros here. Okay, so the first thing I'm going to do is I'm going to start with my P over Q's, okay? So P's have factors of 1, 2, 3, and 6. Q's have factors of 1 and 3. Okay, so P over Q. I kind of wrote that wrong over there when I put the bar there, so maybe I'll just put, those were my P's, those were my Q's, right? Okay, P over Q. So 1 over 1 is 1, and we know it's plus or minus. 2 over 1 is plus or minus 2. 3 over 1 is plus or minus 3. And 6 over 1 is plus or minus 6. So we have those 8 right now. 1 over 3 will give me plus or minus 1/3. 2 over 3 will give me plus or minus 2/3. 3 over 3 is 1. I already have it on my list. 6 over 3 is 2. I already have it on my list. So here's my choices. Okay, I have 1, 2, 3, 4, 5, 6 choices. So that's what my rational zero theorem tells me. Now I'm going to use Descartes' rule of signs, okay? So when I look at my original function, and I know I'm probably writing more than you're ever going to write down, but I'm trying to make it so if somebody's like kind of walking through this, they can see where I'm getting all my values or choices. All right, so right now I'm at positive, then I go negative, negative, positive, positive, right? So I have 1 sign change here. Negative to positive is my second sign change, and I have 2 sign changes. Okay, so positives, negatives, and imaginaries. Those are my choices, right? So maybe I have 2, or I subtract 2 and get 0, okay? So for my positives, I have a choice of positive 2 or 0. That's my choices. I can't have 1. I either have 2 or 0. Okay, so now let me do my f of negative x. So that gives me 3 negative x to the 4th minus 11 negative x to the 3rd minus negative x to the 2nd plus 19 times negative x plus 6. Negative x to the 4th is going to stay positive, so I just get 3x to the 4th, which is positive. Negative x cubed will go negative, times the negative 11 out front will make it positive 11x to the 3rd, so that one stays positive, or goes to positive, I should say. Negative x squared is going to just be positive, so that negative out front will stay, and that's a negative. 19 times negative x is negative 19x, so that one's negative, and plus 6 is never changing, that's positive. So I started positive, I went to negative, my first sign changed from negative to positive, my second sign changed. So the negatives are also 2 or 0. 2 is the first choice, and we subtract 2 and I get down to 0. Okay, so let's list our possibilities. I could have 2 positives with 2 negatives, which means 0 imaginaries. I could have 2 positives with 0 negatives, which would mean 2 imaginaries. Okay, that's if I have 2's, right? Now I could have 0 positives with 2 negatives, which would mean 2 imaginary. Or I could have 0 positives with 0 negatives and 4 imaginary, okay? You should notice that no matter what you get, your imaginaries should always be even numbers. Because if you think about it, your imaginaries always have the value and its conjugate. So you should always have a matching pair in your imaginaries, okay? But for your positive and negatives, we have these 4 combinations, and it's going to differ depending on the functions, depending on the sign changes. Okay, so I guess when I do my guess and checks, I'm going to stick with 2 positives to begin with. I'm going to see if I can narrow it down twice with just positive numbers, okay? So give myself some room. Probably going to lose my equation almost off the top. All right, what's your first guess? You want to go with 1? I like 1. Let's try it. 1. We're going to list our coefficients. So I get 3, negative 11, negative 1, 19, and 6, and I'm trying 1. Bring down the 3. 1 times 3 is 3. Add those, I get negative 8 times 1 is negative 8. Negative 1 times negative 8 is negative 9. Times 1 is negative 9. I add those, I get 10. 1 times 10 is 10. I get 16. All right, bust, right? Didn't work. Let's go for another positive, right? So let's go, you want to go to the next positive, which is 2. So I have 3, negative 11, negative 1, 19, and 6. Bring down the 3. 2 times 3 is 6. Add, I get negative 5 times 2 is negative 10. Add, I get negative 11 times 2 is negative 22 times, or add going down, I get negative 3 times 2 is negative 6. Ding, 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 we got 1. All right. All right, so 2 worked. So we got 1 positive, which means if I get 1 positive, I have to have another positive, right? Because I can have either 0 positives or 2 positives. If I got 1, I have to have a second one. So we have 3, 6, 1/3, and 2/3 to go. I guess just my logic says let's try 3, right? So, and again, you can guess and check all over the place, but I kind of like some order, I'm going to be honest. Okay, here's the deal. Don't forget that this is my new polynomial now, and it is to the 3rd degree because I was in the 2nd or 4th degree, and I dropped 1 power. Okay, so I'm decided I'm going to try 3 as my next one. Don't forget I have 1, right? Okay, but I'm still in the cubed, so I still need to try this again so I can narrow it down one more time. So I have 3, negative 5, negative 11, and negative 3. Bring down my 3 times 3 is 9. I get 4 when I add. I get 12 when I multiply. I get negative 1. Oop, not negative 1. I get positive 1 when I add. And I get 3 times 1 is 3, plus negative 3 is 0. Yes, I got a second one. That's good. Okay, so I get a second one there. Okay, so what I have right now is an x minus 2 as one of my roots and factors, an x minus 3 as another factor, and I have 3x squared, because this was x cubed, so now I'm down to x squared, right? Plus 4x plus 1. Okay, does that last trinomial factor? Okay. I don't know if you see it, but I think there's only one way for 3x, and it's 3x and x. Basically, are there factors of 3 that add to make 4? Yes. So I'm going to do, obviously this is 1 and 1, and everything gets a plus. Okay. So this is what my factors, everything factors out. The first 2 I had to do with synthetic division to get down to those factors. And then once it's down to a quadratic, we have the option of factoring quadratic formula, all those good things. That means x could equal 2 here, x could equal 3 here, x could equal, when I subtract 1 and divide by 3, I'd get negative 1/3, and x equals negative 1. So my 4 solutions here Aha, do you notice 2 positives, 2 negatives? That makes sense, right? So I get -1, -1/3, 2, and 3 for my 4 roots. That means obviously the combination that worked, if you think back up here to Descartes' rule of signs, is, I'm going to change my highlight color, that this was the combination that worked. 2 positives, 2 negatives, and 0 there. We don't always know that. We could have gotten this right here. Maybe it didn't factor, and what we would have had to do is a quadratic formula, and then we could see that we got maybe the complex from there, okay? So this is what's going to frustrate you most of all. It's not a straightforward do this, this, and this, and you get your answer. There's a lot of guess and check. It's cross off, try the next one, cross off, try the next one. Descartes' rule of sign tries to give you some ideas on how you can guess well so that you don't keep trying positives when maybe there's no positives left to get. There's a chance you have no sign changes in your original. If you have no sign changes in your original, then maybe you have 0 positive roots. That's what it's telling you if there's no sign changes. Or if there's no sign changes when you do the negative x, that means there's no negative roots. So Descartes helps narrow it down. Obviously, the rational zeros help narrow down your choices, but you still have to go through your choices to see what's going on. So the most frustrating thing with this section is it might take one of you 2 minutes to get all your solutions, and the next one of you might take 10 minutes because you guessed and checked different numbers, okay? Once again, I can't stress enough, practice, because if you never practice this, it's really tough on the test and quiz for the first time. It really does need some practice. So practice on page 335, 3 through 51 by threes, or you choose some odds that have the answers in the back of the book to go from there. And I can't stress enough to you, don't go find the answers in the back of the book and make your board match it. Because when you get the test or quiz sit in front of you, you don't get that option. So practice it. It's okay to get some wrong answers and cross them off and keep moving, okay? It might take you a full sheet of paper for one problem to guess and check until you get there, okay? Practice it, and let me know if you have questions.